Hello everyone, welcome to our statistics lecture for this week. Today we are going to be covering chapter 3, or measures of central tendency for week 3. On today's discussion we're going to be covering 3 very important statistics. We're going to be covering what's called the mean, the median, and also the mode. The mean, median, and mode are some of the most frequently used statistics that we actually have in terms of the behavioral sciences or in terms of statistics as a whole. We're going to be talking about advantages, disadvantages of the mean, median, and mode. We're also going to be talking about when it is that we want to use the mean, when it is that we want to use the mode, and when it is that we want to use the median, and some pretty important factors that can contribute to the use of all three. Now, let's go ahead and begin by talking about what are measures of central tendency. With the idea of measures of central tendency, think of the following. What I want to do is I want to have one number that best represents my entire group or my entire data set's performance. So how does this work for me? Think of it in the following situation. Let's say, for instance, that you guys were to take an exam. So we have 20 individuals who took an exam. Out of those 20 individuals, I grade all 20. So what I now do is I put all 20 exams with their grades into my bag. And now what I want to do is I want to try to talk about everyone's performance as a whole. So I don't want to talk about one single person's performance. I want to talk about the group's performance. So what I randomly do is I take my hand and I put it into my bag and I pull out a piece of paper and I say, wow, okay, everyone is doing fantastic. Everyone got a 95. Or a 95 was on the exam, so everybody must be doing well. So here we have individuals who may have ranged from getting a 60 to 100%. But now I pull out a 95, and now I'm saying that everyone got a 95. Does that seem really truly representative of the group's performance? And your answer should really be no. That doesn't sound very representative of the group's performance. So what should I do instead? Well, I should really try to find some method that allows me to take everyone's score into consideration whenever it is that I'm calculating that value. And that's where measures of central tendency comes into play. So essentially what we're going to try to do is we're going to try to find one number that best represents a group with some advantages and some disadvantages for all three of the ones that we're going to be discussing today. But ultimately, what we're trying to do is have one value that best represents the group's performance. So actually trying to take everyone's score into consideration to the limits that we actually can in some particular cases. Now, there are three competing options that we work with in terms of measures of central tendency. Now, most of you are pretty familiar with all three of these, but here we're going to review them just in case we're having anybody who's not necessarily sure what we're talking about in these particular cases. But essentially, our three competing options that we've all probably heard of are what we call the mean, the mathematical average, the mode, the most common number in our data set, and also our median, the middle value in our data set. Now, very importantly, one of the things that we find is, one of the things that we find is that normally whenever it is that you're reading a research article or that you are reading some type of empirical paper or giving a presentation, most of the time you really don't have the word mean, median, and mode actually presented on the screen or actually in your research article. Many times what you'll find that the mean, median, and mode are actually given symbolic notations. Now, the symbolic notations that we normally find are the following. For the mean, for instance, the symbolic notation that you'll normally find is the following: capital M or X bar, what we call it. So capital M or X bar, those are going to be the symbolic notations for the mathematical average that we're going to be using this semester. Now, please make sure that you do understand that whenever it is that I use capital M or X bar, they both refer to the mathematical mean. So don't think that just because I used M, it means something different than X bar. They're completely interchangeable. They're synonymous with each other. They're just different symbolic notations, and it's really a matter of preference for the individual. And I like to use both given during the semester, so kind of just be on the lookout, but I'll always make sure to point that out during the semester whenever it is that I'm talking about the mean. I'll talk about, well, capital M or X bar. For the mode, you'll have capital M, subscript O. That's the representation of the mode. And for the median, you'll have capital M, subscript E. Oops, that's a terrible looking E, but you guys get the idea. So capital M, subscript E, capital M, subscript O, and capital M or X bar representing our mean, median, and mode respectively. So this semester I'm going to be using these symbolic notations to represent our mean, median, and mode, because again, that is part of the terminology that I would like everyone to learn this semester, is making sure that you're able to keep these symbolic notations represented adequately. Now, first, let's begin by talking about the mean. What is the mean? How do we calculate the mean? And we're going to try to work out some problems in terms of calculating the mean. So if you do have your calculators available for you, go ahead and pull those calculators out. You can use the calculators on your computer. You can use the calculators on your phone. But I would like for you to be able to use your calculators as I'm going through the lecture. So let's first talk about the mean. What is the mean? The mean defined is essentially the average of the scores, or the mathematical average. Now here, I say that the average of the scores for either x or y, because you all remember in my previous lecture when I was talking about symbolic notations, I made that point that in certain instances we may be calculating for x, or we may be calculating for y. It doesn't really matter here which one you're calculating the mean for. If you were going to be calculating the average, for instance, for y, here in our little formula that we have here, it wouldn't be this e-looking sign here that I'm going to talk about in just a second, and the x, it would be the summation sign and y. And here it wouldn't be x bar, but rather it would be y bar in our particular case. But here for our purposes, I'm just going to talk about x bar and calculating for x. So don't worry so much about y at this point. So what is the mathematical average? Well, in terms of the mathematical average, there are some very major advantages to using the mathematical average or using our mean. The mean is actually the most commonly used descriptive measure, or our measure of central tendency. It is very, very frequently used. The mean is also used in some inferential statistics that we're going to be talking about this semester, so that's actually a very good point for us to talk about in future lectures. One of the things that we also find from the mean is it's the most stable estimate from sample to sample, and I'm going to talk about what that actually means in just a second here. And ultimately, it varies the least when several samples are taken from the same populations, and that's a very, very important issue for us. So going back to our discussion that we talked about in our previous lecture, remember that we have this issue that we're always talking about. We're talking about the population, and that didn't come out so well. So we'll try this again. The population, still not coming out so well. Okay, give me 1 second here, guys. Sorry, some technical difficulties. Okay. So here, still not working out very well, guys. Sorry. A little bit of technical difficulties that we're having. So, okay, there we go. My population. No, as best as it can be, I guess, in terms of my handwriting with this little ink pad thing that I'm working with. The population versus the sample. Okay, and yeah, I don't know why this isn't working out so well, guys. Okay, so let me try something different here because I'm not liking how this is coming out. So give me 1 second here. Okay. Okay, so let's try this. I do apologize that we're having some technical difficulties. No, that's not what I wanted. Okay, so let's go ahead and put it in terms of what we're kind of familiar with in terms of our discussion. Okay, guys, I'm sorry. I don't know why I'm having so many technical difficulties here. I do apologize. Try this again now. This should be part 2 of our lecture in terms of measures of central tendency. So I was talking about this aspect of a population versus a sample. And this is a very important issue for us to talk about. And the reason that this issue is so important for us to discuss is for the following reason. Remember that with your population, we're essentially talking about everyone who fits into that specific characteristic that you're interested in. So let's say, for instance, I care about all individuals who are enrolled in the online statistics psychology class with me in the fall 15 semester at Our Lady of the Lake University. So it doesn't matter what campus you're on, but all I care about is that you are enrolled in this particular class. Now that's the entire population because you all fit that characteristic. Now versus the sample being just the individuals that I randomly select from the population. So let's say out of a class of 25 or 30 people that I have, I randomly pick 10 people to represent my group. Okay, that's what we're talking about versus the population versus the sample. So here, in terms of my average, let's imagine the following situation. Imagine here that what I'm going to do is I'm randomly going to select 10 individuals to participate in my study. Okay, so out of my population, and here we're going to say that my population equals 100 individuals. Okay, but what I want to do is I want to select a group of individuals to represent the population. So here I'm going to select lowercase n, so my sample size. So my sample size here in my particular case is going to be 20 individuals. So out of that 100, I pick 20 individuals. So now what I do is I'm going to calculate the average for those 20 individuals. And here we're going to calculate an average for whatever it is that you want. Let's say, for instance, that you're giving them a memory test. Okay. So here the average that we actually calculate, so capital M, my mean that I calculated for that group's performance is a 4.5 out of 7 items. Okay. So here, that's for 20 individuals that are randomly sampled. But now let's say, for instance, that from the exact same population of individuals that I have, I now select another 20 individuals. Okay? So it's the exact same 100 individuals that I began with, right? So capital N for my previous example. But now I select a new 20 individuals. Okay? So I'm going to select a new 20. So lowercase n equals 20 new individuals from that same 100. Now, potentially I might have a couple of individuals who I had randomly selected before participate. In an ideal world, what I would want to do is I would want to kick those 20 people out and my population now would only be 80. But I really don't want to do that since I want to give everyone an equal opportunity to participate. Okay, so now I select a new set of individuals. So this is a new group from the same population, okay, as the population in the previous example, okay? And this is very important for us. So they're still coming from the exact same population. So if I've already done this study with individuals from that population and their average was a 4.5, I would now redo my study, and what I should theoretically get is I should get somewhere around a 4.5 as my average. Now, is it going to be exactly a 4.5? Probably not. It may be something like a 4, it may be a 4.6, a 4.4, a 4.9, who knows, but it should be somewhere around there. Not a number that's going to be drastically different from the one that I have here, but it should be something that's remotely similar. Now, why should that number be somewhat similar to the one from my previous example? Well, because these individuals are coming from the exact same population. They're getting the exact same materials. They have the exact same characteristics as the other 20 people who had already participated and given me their data. So here, if everyone is very similar to that in terms of the population, I would expect then that if I were to redo my study using the exact same individuals from the population, but now just a different group of people from the population, I should now theoretically get a number that is somewhat similar to that. All right, that's why here we say that ultimately our mean is a quite stable estimate from sample to sample, because here from the population, it's the one that varies the least. So in other words, I take one sample from the population and I calculate the average, and then I take another sample from the population and calculate the average again. My average should remain pretty consistent or constant. Now, there are some limitations to using the mean. The mean in most instances is not a score that actually appears in your data set, or in some instances is not even a score that could potentially actually occur in your data set either. So for instance, you may have scores that are only a 1, 2, 3, 4, 5, 6, and 7, but yet the average was a 4.5. So how did somebody remember 4.5 words that they were supposed to recall? Well, that really doesn't happen, but that's why it's an average. It's an estimate saying, well, give or take, individuals are recalling about 4.5 words. Now, one of the limitations that we also have associated with our mean, aside from it not being a score in your data set, is that it's highly influenced by outliers. And it's a very, very big issue for us that we're going to talk about here in just a second. So here, let's look at our particular example here. And hopefully my pen works just a little bit better in our particular case. So looking at our formula here that we have, for my mathematical average, which again is the sum of x divided by n, as you'll notice there in terms of that formula. So here what we're going to do is we're going to try to calculate um, the mathematical average. All right. So in our particular case, how are we going to calculate the mathematical average? Well, to calculate the mathematical average, this is what we're going to do. So we need to use our formula, which again is the sum of x, divide that by n. One second, guys. Now, using our formula here that we have, which is x bar or capital M is equal to the sum of x divided by lowercase n. And you'll take note here in terms of our formula that we're working with. You'll notice here that we have a lowercase n right here. If y'all remember from our previous discussion, in our previous lecture where we were talking about symbolic notations, we were talking about the difference between lowercase n and capital N. And I made a note that lowercase n refers to the sample. And that's a very, very important distinction that you need to make this semester, knowing what represents a sample and what represents the population. In our particular case, lowercase n represents the sample, thus x bar represents the sample, while capital N represents the population. And this new symbol here that I'm introducing to you, this is called mu, M-U, mu. Now, I know that's a very creative name, right? Mu, mu. But ultimately here, the reason it's called mu is because it looks like an M and it looks like a U, so they called it mu. Now here, in terms of mu, what is mu? Mu is what we call the population parameter associated with the population mean or the population average. So in other words, if we were to sum up everyone's score from the population and divide by the total number of individuals in that population, so taking everyone's score into consideration and dividing it by the number of individuals in the population, we would then have the entire population average. So there would be no need to calculate the sample mean because I could go out and calculate the population mean. But realistically, like I talked about in my previous lecture, the likelihood of us actually getting the population is not likely to happen. So rather, what do? We end up having to settle for using statistics and using our samples, because using our samples here gives us a point estimate representation of the population. So ultimately, what does this mean for us? It means the following. Let's say, for instance, that we were actually able to calculate a sample mean, right? So again, we have 20 individuals who took the exam. I randomly select 5 individuals from that population as a representation of the group's performance, right? Because for whatever the reason, I can't actually calculate the population. I only can get a sample of individuals' performance. So what I do in this particular situation is I calculate the sample mean for the group, but here I'm going to use that new sample mean as a point estimate representation of that population parameter. So in other words, let's say here, and let me get my little tool to write. Hopefully my tool for writing will work this time. Let's see. So let's assume here that we have a situation where we calculate an 84.5 for an exam, right? So again, this is going to be taking into consideration that we only have 5 individuals that we've sampled from the population. So capital N equaled 20 But here, I was only able to sample 5 individuals from the population. So what I want to do is I want to try to estimate what mu would be for the entire population. So again, this is my population here, right? This is my sample at this point. So I want to try to estimate the population parameter. So how do I estimate the population parameter? Well, I'm going to calculate my sample mean. So I'm going to calculate x bar. And here, when I calculate x bar, whatever x bar is, so let's say for instance I calculate x bar and it comes out to being an 84.5. Perfect. So now that I have an 84.5 and I want to try to estimate the group's performance in terms of the entire population, so no longer the sample's performance, because I already know that because I have x bar here, what I now want to do is I want to estimate the population parameter, in this particular case, mu, because that's the population parameter associated with the population mean or the population average. If I know that the sample mean is an 84.5, I'm going to assume here then that mu is going to be somewhere roughly around an 84.5. Okay? Now here, does it mean it's going to be exactly an 84.5? No, it's not going to be exactly 84.5, but it's roughly going to be around 84.5. So here again, it may be an 83.2, it may be an 85.4, who knows? It may go a little bit up, a little bit down, but it shouldn't be something like a 63.4. Okay, so here, if I sampled correctly from the population and their value was an 84.5, I should never get anything that looks like this. And why shouldn't I get anything like that? Because these individuals are a representation of the population. So thus, when I just grab everybody from the population to participate, I should then get a value that is roughly similar to 84.5. Again, that's why I say about an 84.5 in our particular case. So it shouldn't be something drastically different. So thus, what does it mean in terms of this relationship between statistics, such as this, because that's a statistic, and this is a population parameter. So what is the relationship between the two? Statistics are point estimate representations of population parameters. And that's a very, very important relationship that we're going to learn about this semester. That statistics are a point estimate representation of population parameters. So think of that definition. I'm going to say it again. Statistics are a point estimate representation of population parameters. Why are they point estimate representations? And here the key word is an estimate. So we're not saying it's an accurate representation of the population parameter, because again, that's why I say roughly about, right? So here I say roughly about because it's an estimate, because I don't exactly know what the population parameter is. I'm going to estimate it. How am I going to estimate it? I'm going to estimate it by calculating a statistic. In this particular case, I'm calculating the sample mean to then be able to estimate what the population parameter is going to be. Okay? And that's a very, very important relationship here that we have to discuss this semester. So let's look at a table here that if we were to be encountering this, for instance, in a journal article or in a textbook, for instance, and we needed to calculate the average from this information here, we're going to go ahead and trying to do that, right? So how do I actually find the mean for a table that looks like the following? So in this particular column right here, and again, let me make sure I have my pen out. So in this particular column here, I have all my X values. Okay, so here are all my scores. So in my entire data set, I have individuals who scored an 8, a 7, a 6, a 5, a 4, and a 3. Those are my scores in my data set. And again, if you have your calculators available, go ahead and have your calculators out, please. Now here, this column here represents the frequency. Okay, this is the frequency. So in other words, how many times did this value occur in my data set? Okay, so this column here, how many times did the value of 8 occur in my data set? So here, the frequency of the value of an 8 occurred 1 time, 7 occurred 4 times, 6 occurred 2 times, 5 occurred 2 times, 4 occurred 2 times, and 3 occurred 1 time. Okay, and how do I know that? Because here again in this column, it tells me what the frequency of occurrence of each one of these values is. Okay, so again, 8 occurs once, 7 occurs 4 times, 6 occurs 2 times, 5 2 times, 4 2 times, and 3 1 time. And here, this is made up data that I've just made and put it into a table format just so that way we can represent what it is that we would actually be encountering in terms of a data table, for instance. All right, so now the last column here, this is our product term that we actually have. So this is our product made out of multiplying this value times this value. Okay, that's what we essentially did here. We multiplied this times this to give us that. Why did we do that? Well, essentially, this is just to kind of save us a little bit of time. What time am I talking about here? Essentially, let's just say, for instance, you were being a little bit lazy. So rather than writing out all your values in your table, so for instance, one of the things that you could have just done if you wanted to do this, you could have done 8 because it occurred one time. 7 occurred 1, 2, 3, 4 times. 6 occurred 2 times. 5 occurred 2 times. 4 occurred 2 times. Oops. And 3 occurred once. You could have done that, right? So here what you could have done is you could have just added all your numbers up. Because remember, the formula for calculating the average is the sum of x divided by lowercase n. Okay, that's your formula. So in other words, I'm going to sum up my scores. So if you remember from our discussion last time, from our previous lecture, I showed you all how to do some basic symbolic notations, and I showed you that symbol right there, our summation sign, essentially means just to sum up whatever comes up next. So in our particular case, to sum up x. So in other words, to sum up our scores. Now, many times individuals will make the error that they'll just sum these numbers up. So they're going to add 8 plus 7 plus 6 plus 5 plus 4 plus 3. That's not correct. And the reason that's not correct is because they're not looking at this particular column here. So in other words, why do I have to look at this column here? Because this column here is telling me how many times each one of these values occurred in my data set. So in other words, I'm not really adding 8 plus 7, I'm adding 8 plus 28 because 7 occurred 4 times. So 7 plus 7 is 14, plus 14 is 28. So thus all I've done here, just to kind of save us a little bit of time, I've just multiplied these values to give us pretty much new product terms and saving us some time. So what we can now do here is we can sum these scores up, and that would actually give us our sum of x. So in other words, what all we're going to do here is we're going to add these numbers up. So we're going to sum up the product term of x times f in our particular case, so x times the frequency. So in other words, 8 plus 28 plus 12 plus 10 plus 8 plus 3. So if you go ahead and sum those up for me, please, and I'll go ahead and give you a minute to actually try to do that. So again, get your calculators out. 8 plus 28 plus 12 plus 10 plus 8 plus 3 should give us a sum of x equal to 69. Okay? Now here, if you want to do it this other format, if you actually want to add up each one of the individual numbers, just like I've done right here, you can definitely do that. So I can give you a minute to go ahead and do that as well. 8 plus 7 plus 7 plus 7 plus 7 plus 6 plus 6 plus 5 plus 5 plus 4 plus 4 plus 3. And that should again give you 69. And it sure does. So again, that gives you 69. So a sum of x equal to 69. Okay? So here, either way that you want to do it is perfectly fine. If you would like the older traditional route that you can do this that takes just a little bit longer, you can definitely do that. If you want something that's a little bit faster, you can definitely do it like this. Okay, so now what's the next thing I need in my equation? So I already know what sum of x is, and now the next thing I need in my equation is I need lowercase n. So I need my sample size. So where can I find my sample size here? My sample size easily calculated from this column right here, so my frequency column. So how can I actually find my sample size from this frequency column? Just sum up the numbers here. So in other words, add these numbers up. Now, why would I want to do that and that will give me n? Because remember, This column here is telling me the frequency of occurrence of each value in my data set. So in other words, 8 occurred once, 7 occurred 4 times, 6 2 times, 5 2 times, 4 2 times, and 3 1 time. So in other words, all I have to do here is just add up all these numbers and that'll give me my sample size because I'm not missing any numbers in my data set. So here, adding these up, 1 plus 4 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11, plus 1 is 12. So now we know that n is equal to 12 for our particular example. Okay, so sum of x is equal to 69, n is equal to 12. So now to actually find our mathematical average, or capital M, or x bar if you want to call that, all that we now have to do is we have to divide 69 divided by 12. And you can go ahead and do that. 69 divided by 12 should give me an average of 5.75. So there's my average, 5.75. So here I've shown you essentially two different techniques that you can use to actually calculate your mathematical average from this particular type of table here. So in other words, all that you can do is you can write out each of the numbers using this box right here, right? So we know what our scores are. We know the frequency of occurrence. So in other words, no 2s occurred, no 1s occurred, no 0s occurred, no 9s occurred, no 10s occurred. Only these numbers occurred in my data set. Okay, that is a possibility. So here I just wrote out all my numbers, right? The next thing I did is I added them all up, which gave me a value of a 69, because remember I'm following the process in my equation here, that all I'm doing is I'm summing up my scores. So I summed up x. So again, I didn't sum up this column, right? I did not do that. And the reason I didn't sum up this column is because these are only my x values, but I don't know how many times they occurred. I need to look at this particular column right here, that frequency column. So I added up all my numbers, gives me 69. And divided now by the number of values that I have in my data set. I could have counted here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to give me sample size equals 12. Or I could have just added these numbers up right here. So 1 plus 4 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11, plus 1 is 12. So here just summing up the frequencies would have done the exact same thing, giving me a value of a 12. So now I've just divided 69 divided by 12 to give me my mathematical average of 5.75. Now, this is all great to think about, right? So in terms of the mean, this is fantastic that we actually have our mean being calculated for us in this particular capacity. Now, even though that we've calculated our mean, and I'll jump into talking about our overall mean in just a second here, we need to think about what does the mean actually mean? I know that's a weird thing to think about, but let's think about that. So what does the mean actually mean for you? Okay, so think about that. What does the mean mean? So if you had to tell somebody, okay, well, as a group, we got a 85 on the exam. So let's say that you guys take exam number 1, right? So here's exam number 1. And the group average, let's say, is equal to an 85. Okay? Go home and explain that to somebody. Call your parents, tell your significant other, tell a sibling, hey, as a group, we scored an 85. What does that mean? So, does that mean you scored an 85? No, right? Maybe you did score an 85. But you know what? Maybe you scored a 65. So, is the 85 really representative of you? Not really, right? But technically it is. And why is an 85 actually representative of you? Because your score goes into the calculation of the mean, which is a very important thing again to consider. So in other words, when we summed up your scores, we summed up everyone's scores. We didn't say we're only summing up people's scores who passed the exam. We're only summing up people's scores who got an 80 or higher. No, we summed up everyone's score. And that's a very important thing here. So even though 85, you actually didn't get that score, as a group, you all technically did get an 85, so taking everyone's score into consideration. Now, that probably does mean that there were a lot of higher scores than lower scores, thus pulling the mean in the higher direction, but ultimately, the mean does truly represent some aspect of your performance as well, even though you weren't really up to par in terms of the average. You're below the average in that particular case. Now, in terms of explaining the average, how do I explain the average to somebody? Well, essentially, this is the way we would explain the average to somebody. So if somebody were to get an 85, or the group would get an 85 for the exam, this is the way I would explain it. So, as a whole, as a group, taking everyone's score into consideration, the group performed about an 85 out of 100. Now, does that represent everybody? No. Some people may have scored higher, some people may have scored lower, some people may have scored right at the mean. But as a group, everyone performed an 85. So taking everyone's score into consideration, the group performed at an 85. Okay, that's the way that we're actually going to discuss the mean. Now, a very important issue here that I haven't yet touched on that I do want to talk about is this aspect here of of our outliers. Okay, very, very important issue here that we need to talk about, the aspect of an outlier. What are outliers? Outliers are essentially defined as extreme values in our data sets. So in other words, think of values that are what we would classify as abnormal. And this is a very important thing to consider. Whenever it is that we in psychology, for instance, talk about abnormal behavior or abnormal scores, it's not that we're talking about the term crazy. And a lot of people actually misjudge us about that. So if you actually look at psychology as a whole and you see the negative perceptions that people have about psychologists, many times what you'll find is that people will automatically say, well, you deal with crazy people or with abnormal people. Well, technically, abnormal does not mean crazy. Abnormal means infrequently occurring. So normal means frequently occurring. So in other words, the majority of people behave in this particular aspect, thus making it normal. Outliers for us in data function the exact same way. When people score outside of what is normal, so here think of the 85 as being what is normal or what the group as a whole kind of performed. Here, the closer you are to scoring to an 85, the more normal you are. The farther away from an 85 that you are, so for instance, if you scored 100 or a 30 on the exam, we're going to classify you as abnormal and as an outlier. So in other words, you are deviating very much so from the mean. So in other words, you are very far away from the mean. That is essentially what an outlier is. So another way to think about an outlier, think of it like, for instance, if we were looking at all our data points, right? So let's say, for instance, this is 0 and this is a 10, okay? And let's say that the majority of scores were clumping around down here, okay? So that's where the majority of scores are clumping up. But yet there's one score that's all the way over here. So these are all normal. Okay, these are all normal. This one is an outlier. And why is that one an outlier? Because the majority of scores are all in this location, and yet this one is all the way over here in the deep end, very, very far away. So even though their score is a lot higher than everybody else's, and for instance, the higher scores may be better, here they're still classified as an outlier because they scored so far away from everybody else in terms of the group. Okay? Now, outliers are detrimental to the mean. And why are they detrimental to the mean? For the following reason. Let's say, for instance, these are our scores. A 2, a 4, and a 7. Okay? Please go ahead and calculate my mean for me using these three numbers. So again, following here our formula that we have, the sum of x divided by n. So go ahead and use that formula to find my average. So here 2 plus 4 is 6 plus 7 is 13. 13 divided by 3, because again I only have three numbers in my data set, so 13 divided by 3. So if we divide 13 by 3, you'll find that your average is a 4.33. Okay, 4.33. Now here in this particular case, 4.33, this is my average. Okay, you'll notice that it's somewhat similar to all these other numbers. But here now what we're going to do is we're going to change this 7 to a 14. So 2, 4, and a 14. Okay, so now my sum of x becomes a 20. 20 divided by 3, right? So 20 divided by 3. Oops. There we go. So now gives me an average of a 6.67. And here you guys can round off to the second decimal point and that'll be okay. All right, if you guys round off to the second decimal point. So now you'll notice that when we actually went up from having a 7, my average was a 4.33, to now my value being replaced by a 14, my average now jumps up to a 6.67. So you'll notice now that having this number that seems vastly different from these other two numbers that we have in my data set, so this one here is my outlier, now all of a sudden has pulled my mean so high up that it looks like the group's performance is actually doing better than what it really was, right? So now it actually looks like the group is performing higher, when in reality the group should actually be performing a lot lower, but there's that one single score that's pulling my average in that specific direction. So here, having outliers, high numbers or even low numbers, and that's very important too. Let's say, for instance, that everyone scored an 8, a 9, and a 10. Okay? So here we have 19 plus 8, divide that by 3. So 19 plus 8 gives me 27, divided by 3 gives me an average of a 9. So my average is equal to a 9. But now replace the value of an 8 with a value of a 1. So 1, 9, and 10 gives me now 20 divided by 3. And again, we already know what 20 divided by 3 is because we did it down here. Gives me 6.67. So now look at that. So I replaced that 8 with a 1. So 1, 9, and 10. Now all of a sudden, my average drops down incredibly, drops down almost by 3 points. So having that one low score, so now going here in the opposite direction, right, that we have a low score, pulling down my mean. So again, that value of a 1 here is going to be considered to be an outlier as well. So very, very important for us. All right, so now we've already gone through that. So now let's look at this aspect of finding the overall or the weighted mean. It's very, very important for us. In statistics, many times one of the things that we find is that sometimes we have multiple groups that we've actually calculated the average for, or that we want to calculate an average for. So essentially here, what happens is, let's say for instance we have 3 different groups, and here what I've done is I've just labeled them as being group 1, group 2, group 3, just kind of these unidentifying group categories here. It doesn't really matter what they are, but just here we have 3 different groups. So let's say for instance for group 1 we have 100 individuals, and when we summed up all their scores, their sum of X was 300, right? So 300 divided by 100. For group 2, we summed up all their scores, 700 divided by 200. And for group number 3, 1400 as a sum of scores divided by 700. Okay, so now what we want to do is we want to find an overall average. Now, one of the things that you might think of is, okay, well, why don't I calculate the average for group 1, the average for group 2, and the average for group 3, add up those 3 averages, and then just divide it by 3. You could do that, but that's really not the best practice that we would actually use in terms of calculating the overall or the weighted mean. So one of the things that we can try to do is we can do the following. We can combine all our sum of x's, so combining 300, 700, and 1400, combine all 3 of them. In our particular case, it gives us 2400, and we're going to divide now by the total sample size. So in other words, we're going to combine all 3 sample sizes. So 100, 200, and 700. So now that should give me 1000. So now 2400 divided by 1000 should give me a value equal to a 2.4. So let's say for instance that we had calculated the GPAs for group 1, for group 2, and for group 3. So group 1, let's say, was fall 14. Okay. Group 2 was spring 15. And group 3 was fall 14. So ultimately here, let's say for instance, we had 3 different statistics classes that we taught online, and we want to know as a whole what was the average GPA for all 3 groups at the very end. I don't care what the GPA was for group 1, for group 2, or group 3 individually, but I care for everyone as a whole. So here I'm going to sum up all their scores for across the 3 different groups. So the 300, 700, and 1400, giving me a total of 2400. And then dividing by 1,000 because I'm adding up all the sample sizes. So 100 plus 200 equals 300 plus 700 equals 1,000. So now 2,400 divided by 1,000 equals 2.4. All right. And that's the way that we are going to find the overall mean. So why would we actually want to do this procedure? Why wouldn't we want just individual group averages? You could do individual group averages if you wanted to, but here the group's performance is much more important to us across all 3 different semesters in our particular case. And here I said fall 14 again, and I apologize, it should be fall 15. There we go. Okay. So what happens in the case where we actually have some very weird questions? And this was kind of interesting to me that I've been reading through y'all's book, and I used this book many years ago, and I was looking at this and I was like, man, that's such a weird question for us to get. Let's say, for instance, on page 79, where we have the learning check. So if you actually look at the learning check, in terms on page 79 in your textbook, you'll sometimes find a question that looks like the following: a sample of n equals to 6 scores and has a mean of 8. What is the value of the sum of x for this sample? And this is a kind of a weird question to kind of get. And the solution to this is actually pretty simple. To find the sum of x for your sample, you essentially do the following procedure. You're going to take your sample size, or your average, it doesn't really matter which one comes first. What you're going to do is you're going to take your value, 6 times 8. And once it is that you actually multiply 6 times 8, it's going to give you your value of a 48. That value of a 48 is your sum of x. So in other words, this question here is asking you to solve for the sum of x. So if we would have added up all our scores, divided it by 6, my average would have then been an 8. So here all you do is now multiply 6 times 8 given in this particular format, and that will give you your total sum of x. Okay, that will give you your 48. So again, here if you wanted to confirm that, 48 divided by 6, and that'll give you a value of an 8 in our particular case. All right. So that's one weird question that you may get from time to time, and that's a quick solution to this problem. Second, you may find something that looks like the following. One sample has an n equal to 5 scores with a mean equal to 4. A second sample has n equal to 3 scores with a mean equal to 10. If the 2 samples are combined, what is the mean for the combined samples? So again, if you remember back to the formula that I gave you here, that is the combined sum of x divided by the combined n. Here you kind of have to use the exact same formula here that we just that we used in that previous example. For our weighted mean. So here, since again we don't know what sum of x is, because again remember our overall mean, which it's asking us to calculate, is combined sum of x divided by combined sample size. I need to know what my combined sum of x is. So taking our previous question that we had, our previous weird question that we just looked at, that we were trying to solve for the sum of x, we're going to follow the exact same procedure. So for group 1, essentially, we know it's 5 times 4, because again, 5 being our sample size, and 4 being my group average. And then for group 2, my sample size was equal to 3, and my average was 10, right? So here, 5 times 4 is going to give me 20. 3 times 10 gives me 30. So I now know that the sum of x for group 2 is 30, and the sum of x for group 1 is 20. So now I can sum up those sum of x's just like my formula asked me to do here. So 20 plus 30, and we're going to divide here by my sample size. So 5 and 3, because remember, those were my sample size. So I need to combine my sample sizes, 5 and 3, and that gives me a value of an 8. So now we have 50 divided by 8, and if you divide 50 by 8, you will get a combined average of 6.25. And that is your now overall or combined average, just as we have here. What's the combined mean for the combined samples? All right, so those are two questions that here are somewhat tricky, but I've given you some solutions for in terms of how to do that. So if it comes up in your homework, refer back to this part of the lecture, which is very, very important. All right, so now we're going to talk about the mode. All right, so next let's now talk about the mode. The mode is really an interesting measure of central tendency to calculate. It's probably the easiest measure of central tendency to calculate, and it's the one that a lot of people like to use the most because it's so easy, to be honest with you. What is the mode? The mode is defined as the most frequently occurring value in your data set or in your group. So here, ultimately, what are we talking about? We're essentially saying what value occurred the most frequently in your data set. Now, be very, 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 very careful of this. I can't even stress this enough, and it is something that really gets to me every single time I ever read a statistics textbook or a research methods textbook. Under the mode, even the Graviter textbook does this, and it makes me very upset. I would really like to email Graviter and let him know, and hopefully somebody will not post this on his Twitter account or something like that. Please don't do that. But I really don't like it when statisticians do this, is that people will always put under the mode, they will put the following information. There can be what's called a bimodal and a multimodal situation. Technically that's true, but it's used incorrectly in where it is that they talk about it. So for instance, if you look in your textbook, right under the definition of the mode, which is essentially the following: most frequently occurring value in your data set. And if you will take note, it says value. Is that singular or plural? Value. Singular, right? It doesn't have an S, so it's singular. So here we have one value that can occur in your data set more frequently than any other, thus being the mode. That's the official definition for it. Yet, in statistics textbooks and in research methods textbooks across the board, they always talk about bimodal, in other words, you having two means, or multimodal, having three or more means. That is not possible. So be very, very careful with that. You cannot have two modes, bimodal, or three or more modes, multimodal. You cannot have that. The term bimodal and multimodal are real statistical terms that actually apply to other statistical processes, but not to the aspect of the mode. So be very, very careful about that. So if you have two values that occur as frequently in your data set and more than any other values in your data set, you have no mode. So in other words, think of the following situation. Let's say that you have the values 4, 3, 3, 2, and 1. The most frequently occurring value in your data set, in this particular data set here, is the value 3, because it occurs 2 times. So the mode is equal to a 3. Okay? But what happens in the case where you have 4, 3, 3, 4, 1? So now 4 and 3 occur as frequently, so in other words, they occur 2 times each, and they occur more than any of the other values in your data set. So in other words, they occur more times than one, and here they occur 2 times each, right? Many times what people will say is, oh, you have 2 modes. That's what people will say. They are wrong. Very, very wrong. Because again, by definition, you can only have one value in your data set that occurs more frequently than any other, thus being called the mode. Now, where does the term bimodal and multimodal come into play? We are going to talk about that next time whenever it is that we talk about frequency distributions. So I'll talk about that later on, not at this point. Okay, so don't worry about bimodal and multimodal. Only worry about the mode. So if 2 numbers or 3 numbers or 4 numbers occur as frequently and more than any of the other values in your data set, you have no mode. So in this particular instance, in this example, there is no mode. And why is there no mode? Because there is no single value that occurs more frequently than any other value. In this example here, we did, because 3 occurred more times than any of the other values in your data set. All right. There we go. Now, what are the benefits to using the mode? The mode is actually very useful if you are actually ever working with nominal data. So if you guys remember our discussion of nominal data, that we have categories or that we've given numbers to represent specific categories or groups. So remember that we said that, oh, well, males represent a 1, females represent a 2. In that particular case, using something like your mode would be very, very beneficial. So again, let's say for instance you have the following. So let's say that you have participants and you've categorized them as either being a 1 or a 2. Okay, so you start counting up, well, I have 10 participants. 1, a 2, a 1, a 1, a 2, a 1, 2, 2, 1, and 2. Does that give me 10? So 2, 4, 6, 8, 10. Perfect. So now, let's say for instance a 1 equaled male category and 2 equaled female. Okay? So if 1 equaled male and 2 equaled female, and you want to know what category, so which gender occurred more frequently in my data, the male category or the female category? Well, the mode would be very, very useful for that kind of data. So here, what can you do? Well, look at how many numbers actually occur. So 1 occurs 1, 2, 3, 4, 5 times. 2 occurs 1, 2, 3, 4, 5. Wow. So here, the male category occurred 5 times. The female category occurred 5 times. So in our particular case, is there a mode? That's my question. Is there a mode in our particular data set? And the answer is no mode. Because again, there is no one value that occurred more frequently than any other. So let's say for instance we had 11 participants and there was a 1. So now men occurred 6 times, or the male category occurred 6 times. The female category only occurred 5 times. In this particular case now, yes, there is a mode. The mode was equal to a value of a 1, and that represented the male category. Okay, so again, it doesn't represent males directly, but it represents the category of a 1, which is very important. Now, in the case where you're not using nominal data like you are here, that you're not using these categorical data, and you're using continuous data that you're actually having that fall on a number line. So let's say, for instance, that you have values like 1 through 9. So participants answered and they gave you a 2, a 4, a 4, a 2, a 3, a 1, a 2, a 1, and a 7. Okay? In our particular case, let's say for instance that our values could range anywhere from a 1 to a 9. So one of the great things about using the mode is that it's completely unaffected by outliers. So in other words, outliers don't really do anything to it. So here, for instance, if we look in our particular example here, you'll notice what our mode is. Our mode is a value of a 2. And the reason the mode is a 2 is because it occurred 3 times. So I'm not going to write the mode equaling 3 because that's not what it's in reference to. The mode is equal to a value of a 2. So I'm writing here the value of 2. Now, how many times does it occur? It occurs 3 times, but here I write the value of a 2 because that's the number that it's representing as the mode. Very, very important. Now here, very important, as you will notice, the value of a 7 seems to be kind of a little bit out of place. So all these other numbers are right there, right around each other, right around that group of between a 1 and a 4, but now all of a sudden you throw a 7 in the mix, well, it didn't really matter. Let's say, for instance, we change that 7 to a 99. Here, the mode doesn't change anyways. So here, we now have this huge outlier of a 99. The mode is still a 2. Why? Because it still occurs more frequently than any of the other values in my data set. All right. Now, limitations of the mode. A big limitation of the mode is that the mode is not actually very representative of the entire data set's performance. So let's say, for instance, just for whatever the reason may be, let's say that we end up having numbers like the following. Let's say on an exam. So we have people who got an 85, 94, a 93, and a 91. Okay, those are my 4 exam scores. But let's say also we have 2 people who got a 25. So these people were cheating off each other. All right, let's just say for that. So these 2 people got a 25. So you'll notice here now my mode is equal to what? My mode is equal to the value of a 25, right? Because my value of a 25 occurred 2 times. All other values occurred only 1 time. So here, if somebody saw this, somebody would say, wow. So in other words, as the group performed at a value of a 25. Wow, they're doing terrible. When in reality, the group is doing really well. 4 out of the 6 people are performing very well. But these 2 people performed very low, and they just happen to get the same score, thus giving you a mode of a 25, right? So that's not very representative. And that's one of the problems that we actually have with the mode. It's not very representative of the entire group's performance. Now, in contrast to the mean, where the mean takes everyone's score into consideration, the mode really doesn't take everyone's score into consideration. So here in this 25, 85, 94, 93, 91 are not really taken into consideration in its calculation, right? So that's a huge problem for us. Now, you can also find the mode in certain figures that look like this. This is actually what's called a histogram, and we're going to talk about histograms a little bit later on this semester when we talk about frequency distributions. So this is a histogram, or what we also call a frequency distribution. And histograms or frequency distributions essentially display for us all our data. So what you'll notice here on our x-axis, is the scores that were actually given to us on our performance assessment. Okay, so in other words, people got a 1, a 2, a 3, a 4, a 5. On the y-axis, we actually have our frequency of occurrence. So remember our good old friend frequency that we looked at with the mean, that we have that column frequency? Now here, frequency is displayed on our y-axis. Okay, this is my y-axis. So the number of times the score was actually used. So in other words, the 1 was used about 4 times. 2 was used about 6 times, 3 about 12 times, and here these are my estimates, all right? 4 was used 20 times, 5 was used, we're going to say 8 times, okay? So now what we can do very easily to find the mode in something that looks like the following, you find the highest bar in your frequency distribution or in your histogram here that I've produced for you. So you have your highest bar. Your highest bar is going to reference the mode. So in other words, this value right here occurred 20 times. So a value of a 4 is my mode. Okay, so the mode occurred 20 times. Okay, and how do I know that? Because it's the highest bar, and I can notice on the y-axis that I can read the label on here that it says that it occurred 20 times. So it occurred more frequently than any of the other values in my data set. All right, very important for us to be able to determine that from a graphical representation. Now, you'll also sometimes encounter, just like our good old friend, that table that we had with our mean, but now here, rather than saying, how do I find the mean of a table? What I want to do is I want to find the mode of this table. Okay, so I don't care so much about the mean anymore. I care about the mode. Okay, that's the most important part. So how do I find the mode in this particular table? Well, again, think about this aspect of the frequency. So in other words, this column here is telling you how many times each value in my data set occurred. So here again, I know that these are the values that occurred, so an 8, a 7, a 6, a 5, a 4, and a 3. And now I need to know how many times each of them occurred. So here in my data set, you'll notice that 8 occurred once, 7 4 times, 6 2 times, 5 2 times, 4 2 times, and 3 1 time. So out of all these numbers here that we actually have, so these 6 scores that occurred in my data set, which one occurred the most times? Well, the one that corresponds to the value of a 4. So here, 7 occurred 4 times. So my mode is equal to a value of a 7, not to a value of a 4, because remember, 7 occurred 4 times, but the 4 is not the mode. So that's the number of occurrences of the value of a 7. So here in my particular case, my mode is a 7. So very easily, just looking at this particular column, looking at the highest number, tells me whatever the mode is, if there is a mode in my particular case. And in this case, there was. Now the last statistic here that we're going to talk about for this week is the median. And the median is a very important statistic here that sometimes really kind of goes unappreciated and unnoticed. And to be honest, there's a good reason why it goes unnoticed, but to be honest, it does provide us with some information, and it is used somewhat widely, but not as much as the mean. So here, what is the median? The median is the exact middle point of your data set. The median is essentially the point that separates the top 50% from the low 50% of your scores. So in other words, whenever it is that you find the median, 50% of your scores are above that point, 50% of your scores are below that point. So how do I find the middle point in my data set? How do I find the median? To find the median, there's 2 steps to finding the median. What are those 2 steps? Number 1, we put all our scores in order. Here, it doesn't really matter if you put your scores in ascending or descending order. So you can go from highest to lowest or lowest to highest, and it doesn't really matter for you. Okay? The second way, the second step to finding the median is now to find the middle value. So the first step, put all your numbers in order, and the second step, now find the middle value. How do I find the middle value? I've given you all the formula here for finding the location of the median. Very, very important. This formula finds location. So finds the location of the median. Okay? Not the median itself. So a lot of times people will use the formula and say, oh, the formula gave me a 2.5 or it gave me a 3. Well, that's the location of the median, the third spot, or the 2.5 spot. And I'll talk about that 2.5 or whatever in just a minute here, because you may be thinking to yourself, you're kind of abnormal here, right? Haha, get it? I know I'm making statistics jokes. Sorry, guys. I tend to do that. But it's one of those things that you may say, well, how is it 2.5? And I'll show you how to calculate the 2.5 in just a second. But ultimately here, this formula will give you the location of the median, not the actual median number. Okay, and we still have to go find the value itself, because remember, I'm trying to find the value of measure of central tendency. So let's try out an example of your median. So here are your numbers: 90, 12, 12, 14, 25, 26, 23, 24, and 25. So my first task here that I have to do whenever it is that I encounter this data set, I have to put all my scores in order. So here I'm going to go smallest to largest number, or smallest to largest, and we're going to put all our numbers. So here you'll notice that 12 occurred 2 times, right, in my particular data set. Here I have to now write 12 2 times, and that's very important for me to remember. I just cannot write 12 one time, because I say, oh, well, yeah, 12 is there, yeah, it's fine, but I just write the number. I put all my scores in order, so I put 12. No, you write 12 and 12. Do not write 24, because we're not adding them up. So here it's 12 and 12, 14, so here I'm going to cross them out as I'm going through, 23, 24, 25 2 times, 26, and a 90. Okay, so there are my numbers. And I know that the 90, you're looking at it, and that 90 right off the bat, it should look to you like an outlier, because it is, right? And we're going to talk about the effect of outliers in just a second here. So that's an outlier. Okay, so now I'm going to use this formula. So the first thing in my formula that I need to do is I need to find out what n is equal to. How do I find out what n is equal to? Well, I count up how many numbers I have in my data set. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 numbers in my data set. So now I'm going to use this formula. So 9 plus 1 gives me 10 divided by 2 gives me a 5. Okay, so 10, my pen will write, divided by 2 equals a 5. Now here, again, this value here is not my median. This tells me the location of median. Okay, tells me the location. Okay, very, very important. The location of the median. So it's going to be in the 5th spot. That's essentially what that formula is going to tell you. So the median is in the 5th spot. The 5th spot from where? From the end. So essentially it doesn't matter if you start at the bottom or at the top, you're still going to land in the 5th spot. Okay, you're still going to land right in the middle. So here we're going to go and find our 5th number. So 1, 2, 3, 4, 5. There is my median. So again, here, if you want to confirm that, going from the top to the bottom, 1, 2, 3, 4, 5. Still the same number, right? So now my median is equal to a value of a 24. Okay, there's my median. Okay, it's that middle number. So in other words, 50% of my scores are below. So here, 50% of my scores and here 50% of my scores are above. So 50% of my scores are above, 50% of my scores are below the median, right there at that middle point. All right, that's essentially what the median's purpose is, to find out that middle balance. Another way to think about the median is if you want to think about it like a seesaw. Here, think of it as being that middle point as to where there's a perfect balance between all your values. All right, that's essentially the way that you can think about the median, one of the ways that it works. Okay, so what are some of the benefits associated with the median? Let me get rid of that. One of the great benefits associated with the median is that it's completely unaffected by outliers. So remember here in my particular example that I have a value of a 90. It didn't really matter that I had a 90. Let's say, for instance, my median wasn't a 90. It was a 27. So if I put the 27 at the end of the list, it still didn't change that my median was a 24. It was still right smack in the middle. So here, it didn't really matter that that number went higher or lower. It doesn't really affect my median in any capacity. Now, what happens in the case where we have some limitations associated with the median? The median in itself is not sometimes an actual number in your data set either. So just like your mean, your mode will always be a value that occurs in your data set, but the mean and the median sometimes are not. How is this possible? Well, in the case where we have two middle scores, what the thing is that we now have to do is take the average of those two scores to produce the median. Now, how does this actually work for us? It works in the following capacity. So let's say, for instance, my values are 2, 4, 4, 5, and 6. Very easily, my median is the value of a 4. So 2 scores are down here, 2 scores are there, so 50 and 50. My value is right there smack in the middle, right? Or if you want to go with your formula, 5 plus 1 divided by 2 is 6 divided by 2, giving you a value of a 3, right? So the third spot, so it's right there, right? So there's your median. So what happens in the case where I don't have an odd number of values? So I have 2, 4, 5, and 6. Okay, so still using my formula. So 4 plus 1 divided by 2 is now equal to 2.5. Okay, so 2.5. Okay, so remember that's 5 divided by 2 is 2.5. So now again, remember that number there tells me the location of the median. So in other words, it's in the 2.5 spot. So where's 2.5? Well, here's 1, here's 2. 2.5 is right there. So it's between the second and the third value. So how does this work for us? Well, now what we have to do is we actually have to find that middle point between those two numbers. So how do I do that? Well, the first step that I'm going to do is I'm going to sum up those two middle values. So I'm going to sum up those two middle values. So 4 plus 5, giving me a value of a 9. Oops, there we go. And we're going to divide by 2. So my value now is equal to 4.5. Okay, so now that number becomes my median. So the median was equal to a 4.5. Okay, and why? Because it tells me that it's supposed to be right in the middle. So again here, 50% of my scores are below, 50% of my scores are above. So again, still being my middle value. So here, that is a big limitation. So if we don't have an even number or an odd number of values, sometimes your median will not be a value in your data set. Now in other instances it might. So let's say for instance we got rid of the 6 here, so it's 2, 4, 4, and 5. So here again still in the 2.5 spot, so right there. So here 4 plus 4 is 8 divided by 2 is still a 4, so my median in that particular instance would be equal to a value of a 4. Okay, so in that instance, yes, your median was a value in your data set, but sometimes it can be, sometimes it cannot, or sometimes it can be and sometimes it won't be a value in your data set. But still here, we still take the exact same procedure of summing up those two numbers in the middle and dividing it by 2 to give me the specific value of my median. Now, the median sometimes is also not very stable from sample to sample, and that's problematic for us. And here, one of the things that we need to try to do is try to find better methods to actually having a stable estimate from sample to sample. And we've solved that problem by having the mean. The mean is a very good stable estimate from sample to sample. Neither the mode nor the median are very useful in that capacity. Now here, if you noticed, I really didn't give you guys too much discussion associated with the aspect of the median and the mode in terms of how do we actually talk about them. And one of the reasons I haven't really talked about them in that capacity is because that's really hard to do. And I'm going to show you guys why that's so difficult in just a couple of seconds here. Here I've given you guys another example of some values here. If you want to go ahead and find the median for this particular set of values, just so that way you can try out another problem on your own. Okay, so in which specific situations here do we actually use the mean, the median, and the mode? Well, let's say for instance that you actually were using nominal data and you wanted to know which category occurred more frequently than any of the other ones, or you wanted to know what a typical value was in your data set, so what's a frequently occurring value in your data set, the mode would be a very good option because it answers that question. So what value is occurring more frequently in my data set, or what category is the most frequently used category in my data set? The mode answers that question very well for you. If you had questions such as what is the middle value of my data set? So where is the point where exactly 50% of my scores are below and 50% of my scores are above the mean? The median would be an ideal choice for you. Even if there are extreme scores in your data set, the median would be a pretty good method for you to be able to use to be able to identify some good representative value of the group's performance. Now, if you were more interested into really trying to understand the group's performance as a whole, taking everyone's score into consideration, the mean would be an ideal choice for you, and I would strongly recommend using it. Again, there's lots more advantages to using the mean than the median and the mode, and to be honest, the mean is much more user-friendly than the median and the mode. The mode and the median don't really lend themselves to quite a lot of explanation, to be honest with you. So explain to somebody the mode. Well, the most frequently occurring score on the exam was a 74. Okay, what does that mean? Does that mean everyone's score was taken into consideration? Well, no, not really. It just occurred more times than any of the other ones. it's not very useful unless you're really dealing with nominal data, to be honest with you. So using that categories would be very, very good method with using the mode. You're not going to use the mean with categorical data. So there's no reason for you to average out the male and the female category. You're never going to want to do that. The median doesn't really lend itself too much to explanation either. So here, well, the middle point of the middle point of the data set was a 2.5. Again, what does that kind of mean? Well, it's where 50% of the scores were below, 50% of the scores were above. Well, again, does that really take everyone's score into consideration in terms of its calculation of the value? No, not really. It's just an arbitrary point at where we have 50% of the scores below and 50% of the scores above. So to be honest, of the three, which was the most useful? It depends. And that's an answer that you're going to hear me say a lot all semester long, and there's a really good reason why I say it depends a lot, because it really does depend. It depends on what question you're asking. So again, when would you want to use the mode? Well, it depends. Are you working with nominal data? Then use the mode. Do you want to know what a typical value is that looks like in your data set? Use the mode. Do you want to know what 50% of the point at where 50% of your scores are above or 50% of the scores are below this point? Use the median. If you want to know the group's performance as a whole as a good estimate from sample to sample and a good estimate of the population, use the mean. Why? Because it's taking everyone's score into consideration from the population that you've actually sampled, right? And that's an excellent thing that we want to work with. Now, before I leave you all for today, I'm going to post up these two particular questions online for you. And what I would like for you to do is I would like for you to do the following. Go through this yourself and try to calculate for yourself, for instance, with table 3.1 that I provided here for you. Go ahead and calculate the mean, median, and mode for this particular data set here. And do the same here for this bottom part. Now do notice that for table 3.2, we have two groups, the non-humorous sentences and the humorous sentences group. So there are different groups of individuals here that are participating. So calculate for table 3.1 the mean, median, and mode for yourself, and do the same here for table 3.2. Calculate the mean, median, and mode for group 1 and the mean, median, and mode for group 2. Now, I've also provided for you here as an in-class practice a couple of different little data sets here that if you all want to try out for yourselves, you can try to use to kind of give yourselves a little bit more practice. And here for each one of these, find the mean, median, and mode for each one of the data sets, and also find n for each data set. So you need to calculate the mean, median, and mode for time 1 and sample size, and calculate mean, median, and mode and sample size for time 2. Okay, so you can do that for table 3.1 and for table 3.2, and also do it for your in-class practices if you would like to do that. I'm going to go ahead and post up the answers to them tomorrow night, on Monday night, so that way you guys can have them and you can look through the problems and you can see if you were right in terms of your solutions. That is the end of our discussion for measures of central tendency. Just as a reminder, homeworks are due on Friday by 11:59 p.m. Since this homework assignment for this chapter is going to have a lot more hands-on actual writing out of your responses in terms of showing your work. Again, I do want you all to be able to scan or take pictures of your homeworks and upload those to Blackboard, and I will grade those for you. All right. If you guys do have any questions, comments, or concerns, feel free to send me an email. You all have my Google Voice number, and also feel free to do the voice thread that I've opened up for you all on Blackboard and leave your questions or comments here that you may have. As a last point of discussion, we do have a discussion board post that is needed for grading for this Friday. So on Friday by 11:59 p.m. on September 8, sorry, I'm trying to think of the date. Yes, September 18th, yes. You have your initial post that is due, and then on Sunday, September 20th, you have your response to one other of your class members' discussion post. So you have until Sunday to post your your comment about somebody else's post. So please do let me know if you have any questions or concerns, and I hope to hear from everyone soon.